Welcome to Chemistry with Dr. Z. This is a quick revision for Topic 1 in Edexcel, IGCSE, and GCSE Chemistry. We are going to talk about atomic structure and periodic table quickly. So let's start off with elements, compounds, and mixtures. So elements consists of one type of atoms, and they can exist as individual atoms or molecules. They are usually represented by a symbol consisting of one or two letters. And these are some examples. The number 2 for hydrogen, nitrogen, and oxygen represents the diatomic molecules for these elements. Compounds consists of two or more different atoms which are chemically combined, and they are usually represented by a molecular formula or chemical formula that reflects the number of the different atoms in the molecule. So for example, CO2, carbon dioxide, and H2O, water. The properties of the compound is different from the properties of the different elements that formed that compound. Because the compounds consists of elements that are chemically combined, they cannot be separated by physical processes. Mixtures, however, are formed when two or more different elements or compounds are mixed together. There is no chemical bond in between these particles in the mixture, and the one of the typical examples is air, which is a mixture of elements and compounds. The properties of the mixture is a mix of the properties of all the different particles or all of the different components of that mixture, and because they are not chemically compound, they can be separated by physical processes. So moving on to talk about separation of mixtures. So if you have solid with liquid as a mixture and you want to separate the solid, the first one method is filtration. So filtration is used when you have a solid which is insoluble in the liquid, like sand in water. You simply filter the sand, and then evaporation. If the solid is soluble in the liquid, then you can evaporate the liquid, and the solid will remain in the evaporating basin. And then we have the third method, crystallization. Again, if the solid is soluble in the liquid, then you can use a concentrated solution of that solid in the liquid, and then you evaporate part of the solvent with and use high temperature, and then when you cool it down, the solid will then start to crystallize out and precipitate, and then you can collect it by filtration. If you want to separate the liquid, then you're going to use simple distillation. So if you have solid with a liquid and you want the liquid, you use simple distillation. So simply heat the mixture of the solid and the liquid, and then the liquid will evaporate, and then the vapors will go through the condensers, and the will be collected in the receiving flask here. If you have a mixture of two different liquids with different boiling points, you can use the fractional distillation. In fractional distillation, you simply add a fractionating column, and in the fractionating column, the temperature will be higher at the bottom and lower at the top. The liquid with the lower boiling point will reach the top of the fractionating column as a gas, and then it will go through the condenser where it condenses, and then it can be collected in the receiving flask. Now let's talk about the atomic structure and the subatomic particles. So an atom consists of a nucleus, and the nucleus can be found in the middle of an atom. The nucleus consists of or contain two types of subatomic particles. The first one is the protons. So protons are positively charged, and they have a relative mass of 1. And then we have the neutrons, which are not charged, particles which are not charged, they are neutral, and the relative mass is 1. Almost the whole mass of an atom is concentrated in its nucleus. And then we have the electrons. The electrons will move around the nucleus in shells, and the electrons are negatively charged, and their mass is almost completely neglected in the calculation of the mass of an atom because it's too small. The number of positively charged proton inside the nucleus equal the number of the negatively charged electrons that orbit the nucleus. This is why atoms are neutral, because the charge of the proton and electrons will cancel each other out. For any atom, an atom is distinguished by two numbers. The first number is called the atomic number. You can find this number at the bottom left of the symbol of the atom. Atomic number gives you the number of the protons inside the nucleus, and it also can give you the number of electrons. However, the mass number, the one at the top right, the top left, this is the total number of protons and neutrons. So you can simply find the number of neutrons by subtracting the atomic number from the mass number. An example is helium. So helium has atomic number of 2, so it has 2 electrons and 2 protons, while the mass number is 4, which means it has 2 neutrons. The isotopes are a different form of the same elements, which have the same number of protons, but they have different numbers of neutrons. That means different isotope for the same element would have the same atomic number, but they will have different mass number. An example is carbon 12 and 13. So carbon 12 has a mass number of 12, so number of neutrons is 6, while carbon 13 has a mass number of 13 with a number of neutrons is 7. The mass that you find in the periodic table for the element is not the specific mass of one of the isotopes. It's a mixture, it's an average of the mass of all the different isotopes, taking into account their relative abundance. So this is called the relative atomic mass of an element. You can calculate the relative atomic mass of an element if you know the mass and relative abundance of the different isotopes. So if you have two or more, so if you have two isotopes, you can calculate the relative atomic mass by multiplying the percentage of the abundance of isotope A times its mass plus the percentage of isotope B times its mass divided by 100. If you have three isotopes or more, then you can add this plus the isotope C as well in the same way. Now moving on to talk about the electron and the electronic structures. So electrons always occupy shells or what we call energy level. These shells or energy levels have different energies. The lowest energy level is filled first with electrons, and then the other energy levels will start to be occupied by electrons. There is a maximum capacity for each energy level for the electrons. So the first energy level can be occupied by a maximum of 2 electrons. The second energy level or the second shell, 8 electrons, and the third shell, only 8 electrons. A shell must be completely full before electron starts to fill the next one. The outermost shell is called the outer shell. This is the one that is furthest away from the nucleus. The distribution of the electrons in different electron shells is called the configuration. And we can work out the electronic structure or the electronic configuration of any atom by knowing its atomic number, because this will give us the number of electrons. For example, carbon has 6 electrons because it has an atomic number of 6, and then the electronic configuration or electronic structure of carbon will be 2, 4. And then magnesium, it has 12 electrons. So the electronic configuration of magnesium is 2, 8, 2. Let's talk about the development of the periodic table. So before the full discovery of the atomic structure, there were two ways to categorize elements. The first one is through categorizing them by their chemical and physical properties. The second one by their relative atomic mass. The very first periodic table that was created was in the early 1800s, and that was way before the discovery of the atomic number. So the elements were all arranged based on their atomic mass. However, they didn't take into account the properties of the element, so it wasn't of huge help. Then came Dmitry Mendeleev, and he started to create his periodic table. In his table, he still arranged the element based on their atomic mass. However, he also took the properties of the elements into account. So he started to switch the position of the elements to make sure that a group or a column will have elements with similar properties. He also left some gaps in the periodic tables where when other elements were discovered later on, they fitted well into his table. And then the modern periodic table was created in the 20th century after the discovery of the atomic number. So elements were started to be arranged based on their atomic number, not based on their atomic mass. There were noticed that there were repeated patterns in the properties of the elements. So the properties were repeated periodically. This is why it was called the periodic table. The periodic table has columns which are called groups and rows which are called periods. So elements with similar properties form columns or groups. So each group will tell you the number of electrons in the outer shell of all the elements within that group. So group 1 element, this one, will all the elements there will have only one electron in their outer shell, and so on. The number of electrons in the outer shell of any element will govern its chemical properties. So you can actually predict the property of an element when you look at where it can be found in the periodic table where in which group. You can also predict the reactivity, whether it's more reactive or less reactive, because there is certain trend for reactivity in each group. The rows, however, are called period. And each row or each period will represent a different outer shell of electrons. In the periodic table, we can find metals and non-metals. Most of the elements in the periodic tables are metals. Metals can be found mainly on the left, while the non-metals can be found on the right. The main difference between these is that metals can lose electrons and they can form positively charged ions, while non-metals can either gain electrons and give negatively charged ions, or they don't do this. They simply share their electrons. So let's talk about some of the most important groups for us. So group 0 element, this is the group that we find in the far right of the periodic table. Group 0 elements are all inert colorless gases and they are called noble gases. Group 0 elements have full outer shell of electrons, so all of them have 8 electrons in their outer shell, except helium, which only has 2 electrons in its outer shell because it only has one shell of electrons. Because they have a full outer shell, the full outer shell confers stability for the element. So these elements are non-reactive, they are inert, they don't tend to gain or lose electrons because they are already stable, so they will not take part in any reaction. This is why they also exist as monoatomic gases. As a single atom, they are not bonded to each other because they don't need to, because they already have a full outer shell of electrons. Um, Properties of group 0 elements, chemical properties, they are inert, they are non-reactive. Physical properties, melting and boiling point, there will be an increase in the melting and boiling point as we go down the group. And the main reason for this is because of the increase in the size of the atom, increase in the number of the electrons, and increase in the number of the positive charge inside the nucleus, which means that will be the attraction forces between the different atoms will increase, so we will need more energy to break the attraction between or attraction forces between the different elements. And this trend is the same for all the groups, not just for group 0 elements. Group 1 elements are called alkali metals. This is the group that we can find on the far left of the periodic table, and these include the elements here are the lithium, sodium, potassium, rubidium, cesium, and francium. They all, because this is group 1 element, they all have one electron in their outer shell, which makes them very reactive and that gives them similar properties. They tend to lose that electrons to give positively charged ions, +1 ions, and they form ionic compound with non-metals. Reactivity trend. So for reactivity, chemical reactivity, they become more reactive as we go down the group. The main reason for that is that the reactivity, the chemical reactivity is governed by the how easy the outer shell electron is lost. And as you go down the group, the outer shell of electron will become further away from the nucleus, so less attracted to the positively charged ion, so it can be more easily lost. So the element will become more reactive, or the metal will become more reactive. Melting and boiling point, same like group 0 element, will increase down the group. The reaction, first they react with water vigorously and they produce hydrogen gas and metal hydroxide. The hydrogen gas can be noticed as effervescence or bubbles. As you go down the group, the reaction will become more violent because the element will become more reactive. Example is a reaction between sodium and water to give you sodium hydroxide and hydrogen gas. They react with oxygen, so this is the second reaction. With oxygen, they will give metal oxide. Again, they will give metal oxide, and the reaction will become more violent as you go down the group because the reactivity increases. The different metals from this group give different types of oxides. For example, lithium will give you lithium oxide, sodium will give you sodium oxide, and sodium peroxide. So basically, a mixture of oxides. Alkali metals also react with halogens like chlorine, so they react vigorously with hydrogen gas when heated and they give metal salts. So sodium, when it reacts with chlorine, it will give you sodium chloride. Group 7 elements is the group that is next to the left of group 0 elements, and they are called halogens. They all exist as diatomic molecules. The most important members of this group are fluorine, chlorine, bromine, and iodine. They are all nonmetals because we can find them on the right hand side of the periodic table, and because they are group 7, that means they have 7 electrons in their outer shell. And in order to reach the stable configuration of a full outer shell with 8 electrons, they tend to gain 1 electron. They mainly do that when they react with metal. While with nonmetals, they don't gain electrons, but they rather share electrons with other nonmetals and they give covalent compounds. Reactivity trends for halogens, you're going to notice that for chemical reactivity will be the opposite to group 1 element. So reactivity of the halogens will decrease as we go down the group. The main reason for that is again because the outer shell of electrons will become further away from the outer shell of electrons will become further away from the nucleus. That means the attraction force will decrease. So to gain electron, it becomes harder for the atom to gain electrons now as the size of the atom increases. So reactivity will decrease down the group. Melting and boiling point will increase down the group because of the increase in the size and increase of the interaction or the forces of attraction between the atoms. The reactions of group 7 elements or halogens, first they react with metals to form ionic compounds. So the metals will tend to lose electrons to give positively charged ions, while the nonmetal will gain electron to give negatively charged ion. And then there will be electrostatic interaction between the positive and negatively charged ions, and they will form ionic compound like sodium chloride. With nonmetals, they don't gain or lose electrons, but they rather share the electrons and they form covalent compounds. Example of this is hydrogen chloride. There's another type of reaction for halogens where the more reactive halogens can displace the less reactive ones. The reactivity of the group will will decrease going down the group. That means that the halogens, which are at the top, can displace the one below them from their salts. An example is that we have chlorine, which is above bromine and iodine. So chlorine can react with the salts of bromine and iodine and displace them. So chlorine can react with potassium bromide and it can displace the bromide to give potassium chloride, salt of chloride, and then bromine as an element. It can also do the same with iodine or iodide salts. However, iodine cannot displace chlorine or bromine, and bromine cannot displace the chlorine from its salt. The last thing we're going to talk about is the transition metals. So transition metals are these metals which are found in the center of the periodic table. Transition metals are still metals, so they have the typical properties of metals like heat and electricity and conductivity. They are strong, shiny, and dense, but they have some unique properties as well. So the first one is that they can give you more than one ion. So they can lose one or two electrons or can lose two or three electrons. So they give different positively charged ions like copper. So we have copper plus and copper 2 plus. The metal ions are colored. The transition metal ions are colored, so the compound that contain the transition metal ions are colorful. Transition metals can make good catalysts, so they are used as catalysts. They also, when we compare the transition metal with group 1 elements, for example, you're going to find that transition metal are much less reactive. So, for example, they mostly don't react with water and with oxygen, unlike group 1 metals. They also have much higher melting points compared to the other elements because the transition metals have a very unique properties, they have unique uses as well. So some of these examples are gold and silver. Gold and silver are among the transition metals because gold and silvers do not react with water and oxygen at room temperature, and because they are malleable and can be hammered into shape, they are usually used in jewelry. We have copper. Copper has good conductivity of electricity and it's ductile, can be shaped into wires, so it's usually used in making electrical wires. Iron is in itself is too soft to be used, but when we add another element to iron, we make an alloy called steel, and steel is much harder and stronger than iron and still can be hammered into shapes. So the steel iron is used as a steel. However, steel and iron has a disadvantage of being reactive with water and oxygen over a long period of time, and they can form rusts. This is why iron and steel should always be protected from air and from water by a layer of paint, for example. Finally, elements like chromium, nickel, and iron, they are make good catalysts and they are used in chemical industries. Now we get to the end of the revision of the first topic, topic 1. If you want to have a more precise and more detailed explanation of the topics, please go into my channel, subscribe into my channel, and you're gonna find the videos specific to each topic of these with details and examples, specific examples. Thank you very much for watching and don't forget to subscribe to my channel.